Greetings everyone through here. Welcome to the Demohub. Welcome to the demo for today. Today's demo, we're going to be taking a look at a modern data tool called Continual.ai. What exactly is Continual.ai? We're going to dive into that, unpack the features, and orient ourselves around its capabilities. According to the website, Continual.ai is a leading operational AI platform for the modern data stack that helps teams build predictive models that never stop learning and improving, which does make sense with the continual part of the name. I can think about this as continual AI, continual learning, continual prediction, and the whole like. So let's jump into the demo. The very first thing you can do is sign up for a free account, which we've done, and it brings us into this page, which is the development environment. To the left is the navigation pane, and to the right is the canvas where work is being done. Now, I've explored this for a little bit, so you might see some of my trainings, but I'm going to go in step by step to orient yourself around the tool and some of the unique capabilities. Just for a caveat, as always, the focus with these demos is not to highlight the specific UI at this current point in time of the tool, but more so to highlight the capabilities being built by the product. The UI can always change, but the capabilities and the problems being solved is something that does carry along. So let's jump in. There is a settings. Teams can be invited to collaborate. In here, there are dashboards, features right off the bat. This is telling us there is ability to create and manage features, some form of a feature store. There are models and ability to manage change and different environments for development. So dev, test, stage, production, UAT type environment. Now let's jump right in. The space of AI is a very vibrant space. Sometimes it could be very disorienting to understand what tool is doing what. Is this for training? Is this for AI? Is this for MLOps? We're going to dive right in and unpack that. So the very first thing we can do in here is to create some predictive models. Now, putting the persona of someone who is not a data scientist, your everyday user of your data warehouse platform, in this case, Snowflake, who wants to have the power of doing machine learning at their fingertips without the complexity, without the low level work it takes to train models, deploy them to productions. That honestly scares a lot of teams away. What Continuous AI is promising to do is to be that abstraction on top of that, where you can create these models in a very low friction way, and Continuous AI takes care of the low level work of deploying and versioning and managing and the feature states and the feature engineering and all of that. So a very fascinating space to look at. So that's it. Let's jump in. Here we're going to create a predictive model. It does come up with the data store. Continue.ai does take that data warehouse centric approach to AI ML, where the work and the predictions being done is leveraging your infrastructure for data storage. So in this case, the data would already be in a data warehouse, being loaded by ETL tools, being developed by your engineering team, and now taking this further to build the ML models on top. Here, there is some bank marketing data sets coming in, housing, tweets, and telco. For the demo, let's leverage the banking marketing data set. I'm going to copy that to the right. We can explore that by selecting the data from that table. If we go ahead and preview this, we can see the data sitting in that table, and it does highlight what the columns are categorical values as well as numeric values. So if you're going to be doing some predictions, typically some of these variables will be relevant with predictive power and some might not be. So here we're seeing all the values, let's say month, category, day of week, campaign. And if we're going to be looking at campaign effectiveness, does the day of week matter when the campaign goes out, and a whole lot of other values that could potentially have predictive power. Now, if I'm a data scientist and I want to go in and open up, Python and PyCharm and go down to the low level work, you certainly can. This reminds me of when Hadoop came out, and there were folks that would literally be writing MapReduce and mappers and combiners, partitioners and reducers at the very low levels. It does give you the knobs and dials to really tune in for performance. But naturally, that led to more abstraction like Peak and Hive, and to even more abstractions like Snowflake, which just brings more simplicity. So AI is definitely seeing that renaissance where a lot of the complexity for machine learning and AI is getting abstracted into this more declarative approach. That said, with a little bit of a rant, let's go in here. We've seen a table, and this table is already being loaded into your data warehouse. The data science team doesn't have to have a separate environment to take it from here. Again, Continual.ai is really taking a more declarative approach. Instead of you going in and trying to write the model, you just tell it what you want, and it should give you the results. Here, you can give it a name, define the schema, and some other configurations that are available where they should predict the target column you wish to predict. So let's say we wanted to predict a loan, or we wanted to predict NRO, employed, number of years employed. I'm sure that's what it means. Or campaign duration. Any of this you can choose to predict. Just because we're doing the out of the box demo for this, let's go ahead and define schema. Let's call this Demohub, and we're going to use the index as ID. The target we want to predict would be a loan. Here, we're going to predict if loan should be granted to these individuals or not. Again, in a very declarative way, we'll say what we want, not how we want it, which is what SQL really did. And that's why SQL is such a popular language, as opposed to your procedural languages where you have to tell it what to do. Here is a more declarative approach. There is an argument to be made that because it's declarative, it could be so simple that people freak out, just like people freak out that SQL is so simple and they want to go back to write Python. But that's really up for personal tastes and preferences and unique scenarios. So let's jump in here. We have the model at Demohub. We have the attributes. There is some latitude to decide what attributes you want to be active or to be included as part of the predictions. As part of the data exploration, it might be very apparent that certain values have no predictive power. So maybe in this case, duration has no predictive power. I doubt, because usually it should. But if I go into like previous, if it's all null, by just looking at the example data, the data is consistent, most likely that has no predictive power. So you can go ahead and exclude that. And there are other few knobs and dials here and there, which seems like you can use. Now, with that said, we can go ahead and set some policies. This is where Continual.ai really becomes even more unique, because contrary or in opposite to the traditional way of doing AI ML today, where it's really the model-centric approach. You connect to your data warehouse, you grab the data down, you build all these models, you're running them in Kubernetes clusters, you're having to manage that infrastructure, putting a lot of ML ops around it. And frankly, very effective work, but also very low-level work. Once you have your model, you're deploying that to an endpoint, and then you're connecting back to your data warehouse and using that for inference, it can get very cumbersome really quick. But here, given the name Continual.ai, really double clicking on the continual, you can essentially select how often you want this model to be retrained. It's that easy. Think about what has to go into ML Ops to allow for you to retrain your model, say every single day. Essentially, you have to go back to your data warehouse and copy that data down every single day. And teams just really cannot do it. Creating one model is easy. Creating one model every single day, now we're talking. All right. Analogy I'll give here, and I'll get off from my rant, is think about YouTube. Making these videos, creating one video and demoing one product, easy. Anyone can get on a computer. If you want to do it, you can do it. Demoing hundreds of products every single day, now you have to have a workflow to do it. And having a good abstraction on top of this is really what Continual.ai seems to be doing. So here, we're going to say train this model every single day or weekly, monthly, whatever the schedule is. There's also the cron option there if you want even more lower granularity for the training. Let's see the advanced options, accuracy, and trainer size. So pretty interesting. So depending on your data set, you might want to check in some of the advanced concepts there. I haven't explored those yet. Then what are the policies? The latest model versions are automatically promoted, best version or manual. Let's select the best version. And then predictions schedule. How often should you do predictions with this model? So let's do hourly. And this is again, very, very important, because there is that saying, and I know it's almost a cliche making this comment at this point, that in the industry, 80% of models never make it to production. It just sits on somebody's laptop in a Kubernetes cluster somewhere. And the reason for that is because taking things to production and doing inference and predictions is not a trivial task, especially when you think about doing it at scale with not one model, but potentially hundreds of models, which is why ML Ops is becoming such a big thing. that practice is developing to really deal with things like that. So here we're seeing Continual.ai really abstracting that by pointing to the same table that we pointed to, selecting the attribute we want to predict on, uh, telling how often we want to train and how often we want to predict. I can't emphasize how simple this is, right? It's to that point where it becomes so simple and you might almost confuse it for triviality. But it's being simple doesn't always mean it's trivial. It's very fascinating. There are other tools in the market that do the automation of AI and machine learning. Again, our job here is highlighting modern data tools. I think that this approach is very fascinating, using a more declarative way. I haven't written any single line of code for me to make this work. So let's go ahead and review this. Now we have the create, the profile, the train, the promote, and then the predict. So these are essentially the steps that Continual.ai would do based on the declarative input we've put in for this to work. Now let's submit this for the model to be created. I'm sure it will take a few seconds to go through all the training, but we'll see how that goes. So the model was created, the features, 22 features added as part of that. And the profile is being created. It's going to do training and then promoting and then predict. So let's see if we can go in to see the model. So this is the warehouse table being used. This is the prediction view that the model will leverage. The predictions history table should show up here. And I'm sure we can go back and query this if we wanted to. But let's give it a few seconds for the rest to train. So our training and the inference are completed and all the steps were successful. Now, I'm not a data scientist by training. I can definitely hold my own when it comes into this space, but there is definitely the admission that doing this is way more simpler than having to open up a Python environment and trying to create the model from scratch and deploying that into Kubernetes clusters and managing that with feature stores and all of the work that goes into it. Here we can see the 22 features we added. The data was profiled. It did train. It took about 3 minutes for the training. 8 seconds, 3 or so minutes as you expect. And when this ran, it went through a whole list of different models. And apparently the weighted assembler L2 is the winning model based on the models it went through. I saw it go through the Lite GBM and a few other models being tested, but it seems like this is the winning model. And it promoted the model and did our inference and did our predictions on that. And if we go into it, we can see the predictions or the inference based on the model that was selected. It's pretty fascinating. And if you click on this, you can see the models that it tested. Extra tree, Entree, XGBoost, of course, I'm not surprised, Neural Net, Fast AI, Lite GBM, XT, and a linear model, and a few more. Going through this list and testing them, it did pick the weighted assembler, and that's the model that is being deployed. So a very fascinating concept. Now think about the simplicity of this. Going back to SQL, if you really want to write SQL and understand what's going on, you can go in and understand compiler theory or language development before you write SQL. But today, most people don't go to that level. You essentially use SQL to tell you what you want, and you let SQL do the rest for you. So what we're seeing as AI and ML is getting mature. Teams that are looking to leverage this would really be looking for that abstraction to say, hey, I want to solve my business problems. I want to predict my customers' churn. I want to detect failures in my manufacturing line. I want to get efficiencies around my marketing campaigns and really focus on that as opposed to going low level and how do I create MLOps pipelines or how do I spin up Kubernetes clusters. And so that natural progression, if things go the way the industry tends to go, would lead to abstractions and tools like this really coming into market. Very fascinating tool. There is some capabilities too for creating feature sets, almost like a feature store. But again, this is pointing to the feature sets sitting in your data warehouse. So really having that abstraction around your data warehouse for AI ML seems to be what the team is doing. Let's go to production and see if I have some feature sets that were created. No, I don't. And the features here, I'm guessing, are the features that were used for the model that we train. And I can click on the feature. You can see the training that was done on that feature, the prediction history. Maybe this is an option to really be almost a feature store for the organization. I haven't tapped into this very much yet, but it does seem like that's a capability. Let's go back one more time here and browse our data store. I'm using the sample data set here, but of course, if you're going to be using this for your environment, you'll be connecting to your own Snowflake instance. These are the inferences we did. This is the sample data. The inference we did all shows up within the schema. I think I did the last one in the dev schema. One of the predictions I did was customer accept offer predictions. So let's copy that. We're going to write our own SQL. And in that SQL, let's take a look at what is in that prediction. And let's limit that by 10. With any luck, we should see some results there. Otherwise, we're going to check the other one. So there you have it. The predictions are nulls, but I'm guessing it might just be the data set we're looking at. But in the ideal world, the predictions should all show up here, just like that. Again, can emphasize how simple this is compared to really going down on a low-level approach. Now, there might be scenarios if you're Uber or one of those high-tech companies where you have specialized use cases and you have an army of PhDs you can deploy at those use cases. Then sure, going low level would make sense. But for teams that are already standardizing around Snowflake and are looking to have that abstraction on top to even take that platform further with AI ML, with teams that are not necessarily PhDs in this field and want a declarative approach, this seems promising to do just that. Now, we're still probably at the very early innings. I'm not sure how robust these models are, how accurate the predictions are in terms of testing and validation. But if it promises to do what it does, then I would say it's a very fascinating tool. So there you have it for today, a demo on Continual.ai. Hopefully this gives you some orientation around the product and the tool. If you want to check it out, we're going to leave links in the description below as always. If you have topics you want us to make videos or orientations around, don't hesitate to let me know in the comment section below. I will see what I can do. Again, thanks for watching. This has been Fru with Demohub. I will see you in the next demo.